All right, today we're going to learn about solving systems of equations with the substitution method. The way that the substitution method works is you have to know what one of your variables is, and then you plug it into the other equation. Let me show you how that works. In this example, we already know what y is. Y is 3, and I know that because our problem says so. What I can do, since I know that y is 3, is I can take this y in the system, this y, the second y right here, and I can change it to 3, because I've been told that y is 3. Now I want to figure out what x is, so I have to get x by itself. Let's take 3 away from both sides, and let's say 6x equals 6. Now what I need to do is I need to divide both sides by 6, and I get that x equals 1. So my solution as an ordered pair would be 1 for my x, comma, 3 for my y. So my solution is x is 1, y is 3. Let's try some examples where we don't know right off the bat what the y or x are. In this example, we have to start by figuring out what either x or y are. Now we can choose which one we want to figure out. We could figure x out first, or we could figure y out first, but I'm going to choose y, because when we look at the second equation, we already have a y here by itself. And it's really easy to use if you have that situation, because all you have to do to get y completely by itself is subtract 3x on both sides. And I'm doing this to the bottom equation. So what we're left with on the left-hand side is just y, and on the right-hand side we now have negative 3x plus 5. So that's what y is. Y is negative 3x plus 5. And since y is negative 3x plus 5, that means that this y in the top equation is also negative 3x plus 5. So what we're going to do is we're going to rewrite the top equation, 4x plus 8 times, what is y? Well, it's negative 3x plus 5, and that is 20. All right, so let's distribute that 8. And what we get is 4x minus 24x, because 8 times negative 3 is 24, plus 40, because 8 times 5 is 40, is 20. Now all we need to do is combine our like terms. So 4x minus 24x, well, that's just going to be negative 20x. What we need to do, I'm going to go ahead and continue this over here because I'm running out of room. And I'm going to say, okay, I'm going to subtract 40 from both sides. And we're going to get negative 20x equals negative 20, because 20 minus 40 is negative 20. Now I got one more thing I got to do to get x by itself. I got to divide that negative 20 on both sides. And I get x is a positive 1, because a negative divided by a negative is a positive, and 20 divided by 20 is just 1. So I have my x, I need to figure out my y. And you can plug it into either equation. I'm going to choose my second equation because it looks easier. But to find my y, we know what x is. It's right here. We're going to plug it in for the x right here. All right, so instead of 3x plus y is 5, I now have 3 times 1 plus y is 5, because x is 1. So that becomes 3 plus y is 5, since 3 times 1 is just 3. We have to take 3 away from both sides to get y by itself, and we're left with y equals 2. So as an ordered pair, what I have is I have my x first, 1, comma my y, 2. So my solution is x is 1, y is 2. 1, comma 2. And that's it. Let's try some more examples. Right, let's try another one. On this one, I'm going to go ahead and get the top equation and use that one to get a variable by itself. I'm going to get x by itself. So let's go ahead. We have 2x minus 3y equals 5. I'm going to go ahead and add 3y to both sides so that I can get x by itself. And what I get is 2x equals 3y plus 5. What I need to do is I need to go ahead and divide everything by 2 to get the x by itself. So x equals 3y over 2 plus 5 over 2. And now that I know what x is, I can move on to the second equation and replace that x with what it is. So instead of 4x, it's now 4 times 3y over 2 plus 5 over 2 minus 6y equals 10. And it's distribute time. So I'm going to go ahead, 4 divided by 2 is 2. 2 times 3 is 6. 2 times 3y is 6y. 4 divided by 2 is 2. 2 times 5 is 10. Minus 6y just comes down from the top, and the 10 just comes down from the top. Now what we're going to do is we're going to take a look at this positive 6y and negative 6y. When we combine like terms, they cancel each other out. And we're left with 10 equals 10. When you get a number that equals the same number, or you get a letter variable that equals the same variable, then that means you have infinitely many solutions. It is a special kind of solution called infinitely many solutions. Sometimes you may also just say same line. These are the same line. I'm spelling solutions wrong. Let me fix that real quick. Infinitely many solutions. And there we go. That would be our answer. In this example, I'm going to be taking a look at the second equation, and I'm going to be moving the 3y over so that I can get x by itself. That is not the only way to solve this problem, but it's the way that I chose to do it. So let's go ahead and make that a better looking 3, and let's move it over. So we're going to add 3y to both sides, and we get 6x equals 3y plus 6. Now we're going to divide everything by 6 so that we can get x by itself. And we get x equals, well, 3 divided by 6 is 1/2. So we could just say y over 2. And 6 divided by 6 is just 1. So now we figured out what x is. Let's go to the other equation and plug it in. So for the top equation, we have 3, but we now know what x is. It's y over 2 plus 1 plus 2y equals 7. Now we're going to distribute that 3, and we get 3y over 2 plus 3 plus 2y equals 7. Now we need to combine like terms, but the problem is this is 3y over 2 plus 2y over 1. To make 2y over 1 a fraction, we have to multiply the top and the bottom because whole numbers are technically over an invisible 1. So if we simply multiply the bottom by 2 and the top by 2, we can make it a fraction that looks like this. So we can add it. So let's do that. 3y over 2 plus 3. 2 times 2 is 4. And 1 times 2 is 2. Now we can combine like terms. Combine like terms. And there was a plus in the middle that I forgot to bring down. Sorry about that. So 3 plus 4 is 7. So we get 7y over 2 plus 3 equals 7. Subtract 3, and we get 7y over 2 equals 4. Right, now what we need to do is multiply both sides by 2. Get rid of that fraction down there. And we get 7y equals 8. 7y equals 8. Now we divide both sides by 7, and we get that y is 8 over 7. Not the most friendly solution, but sometimes your solutions will be like this. I'm going to circle it so I don't lose it. Now I'm going to plug this into the other equation, the original one. So we have 6x minus 3y equals 6. Well, we know what y is now. We know 6x minus 3 times 8 over 7 equals 6. 6x, negative 3 times 8 is negative 24. So negative 24 over 7 equals 6. Now we need to add 24 over 7 to both sides. And when we do that, we get 6x equals, I'm going to go ahead and start erasing some of this stuff to make some room. Just because we're running out of room. All right, so what we're going to do is we're going to add 6 plus 24 over 7. Now we have 6 over 1. To make it over 7, we multiply the top by 7, we multiply the bottom by 7, and we get 6 times 7 is 42. So we get 6x equals 42 over 7 plus 24 over 7. Now, 42 plus 24 is just going to wind up being 66. So we get 66 over 7. Now what we need to do is we need to divide both sides by 6. Divide both sides by 6. And what we get is 66 divided by 6 is 11. So x would equal 11 over 7. So if we wanted to put this in an ordered pair, it would be x is 11 over 7, y is 8 over 7. And sometimes in these systems of equations, you're going to get answers that are fractions like this. So don't worry if your answer is a fraction. Sometimes that really is okay. Let's go ahead and try another one. I'm going to get the y on top by itself. So we have 2x plus 3y equals negative 5. To get the y by itself, I'm just going to subtract 2x from both sides. And we're left with 3y equals negative 2x minus 5. I'm going to divide everything by 3. So that y is now negative 2x over 3 minus 5 over 3. And since that's what y is, I can now turn to my second equation and replace the y with what it is. Negative 2x over 3 minus 5 over 3, and it equals 7. I'm going to distribute, and what I get is 4x. 6 divided by 3 is 2. 2 times negative 2 is negative 4, and there was an x on the end. I'm getting the x from right here. And then 6 divided by 3 is 2. 2 times negative 5 is negative 10. All right, now notice this. The x's now cancel because positive 4x minus 4x is 0. There's nothing left. And we're left with negative 10 equals 7. Now, is there any universe, any possibility where negative 10 and 7 are the same number, where negative 10 and 7 are equal to one another? And the answer is no. Negative 10 never equals 7. And there is no solution you can have to make this work. So the answer, when you get a number and a different number that says that they're equal, when you see a false statement like this, because negative 10 does not equal 7, that is a false statement. What you have when you end with a false statement is no solution. No solution. And that would be the answer to this.